Greetings, everybody. My name is Peter Dyke. Welcome to another edition of the Alliance's webinar program, where today we're delighted to talk about inspection of fusion as well as polyethylene pipeline systems. Shannon, Dave, and Rick, please come on. First one on gets to go first. Shannon, you're up. Tell us who you are and what you do.
All right, thanks, Pete. Shannon Land with Macro Manufacturing, and I do market development here. Been touring around with the Alliance since forever and preaching the gospel of everything HDPE.
Yeah, you have, and thank you once again, Shannon, for appearing. Rick Ponder.
Yes, I'm Rick Ponder with Integrity Fusion Products. I take care of all of the electrofusion training, both the small and the large diameter, and I'm also the product technical support. So if you have any questions or needs on that, I'm usually the one you'll talk to.
Well, you've taught us a lot about electrofusion over the years, so thank you for that. And finally, Dave Mosier, are you there?
I am here. Can you hear me?
Yes, we can.
Fantastic. I'm excited to be here today, Peter. We take the whole inspection. It's kind of a holistic approach here at Core and Main. So we're looking forward to talking about this, how it starts at specification and ends at pressure testing. It's a great program you put together here today. Thank you.
Yeah, thank you. And I assume that your video off because you're having connectivity issues, and that is fine. Okay. And we also have a bench, and guys and gals on the call, we have these experts on the bench who will respond to your Q&A. And it can be on any polyethylene related issue. It doesn't have to be with what we're talking about today, but we know that there's a lot going on out there and it doesn't necessarily line up with inspection. So please ask your polyethylene related questions. Thank you to Dan, Allen, and Ian. Ian is the new guy and he's learning all about polyethylene. And one of the ways he learns is with questions. So please ask them. So everything we're going to talk about today is related to one of these three rectangles in that image on the left. Is it a process? Is it training? And how does verification occur? With the process, we do want qualified operators. This is one of the key distinguishing features between polyethylene installation and the legacy materials. We do want you to use the data logger. That's a proprietary product from McElroy, but all of our distributor partners sell the thing, and it's available for sale or for rent. And the cool thing about the data logger is it helps the operator do butt fusion, and it provides the inspector or the owner the ability to review that butt fusion even though they were not there. Critical element, fantastic tool, and it keeps getting better every year. We want you to use good procedures. Procedures are key. The specifications are also key. The utilities that have had issues with fusions and pipeline installations that are polyethylene generally always relate to specs and procedures. So that's why we spend so much time talking about it. Training is critical for your inspector staff and the techs that are doing the fusions. This is a key difference between us and legacy materials. If you don't understand how to fuse it, you're not going to be happy with your polyethylene pipe. It is more complicated than legacy materials. It's not just putting the bell and spigot together, but the payoff at the end is you end up with a product that's going to last hundreds of years, and that toward the end of its life, it's not going to fail at the bell and spigot. It's not going to tuberculate. We also ask that your inspectors know that we want the techs to prove to you that they are current with their training. That means they have a card that says, hey, I've been trained within the last 24 months. It's that simple. And often, many of our distributors will provide that training to these new contractors because they're new ones getting into this all the time. They will provide that training to those contractors so that when they get the bid, they're trained before that notice to proceed hits the street. And then finally, we're looking at verification. How do we verify that what was done correctly? We do destructive testing, we do pressure testing, and we ask that inspection occurs and that these inspectors that are used to doing PVC and ductile iron inspections are now acquainted with polyethylene. So that's what we're up to. As far as fusion certifications, there are butt fusion certifications. So if you show up on a job site in your F-150 and there's a guy out there doing butt fusion on Tuesday, but Wednesday it's going to be electrofusion day, that's a separate card. That's a separate training. We want you to check these fusion certifications generally at 3 times. We want to make sure your bidders have the qualifications. So that's a pretty good time to do it. When they show up out on the job site, we want you to check their certs, because sometimes these contractors will not deploy the guys whose creds they gave you at the bid time to the job when it starts. And then finally, when we change the techs on the job, make sure the new guy has those credentials. In that image on the right, we've got my Dan Landy, along with Greg Elwood from ISCO, holding out their cards at a recent event we did with Greg up in New Jersey. Everybody in this business has a card. And, I've got one that's a little out of date. Don't bust me on that. But they all have dates on them. And our distributors, like Dave Mosier from Corin, Maine, on the call today, they do training. In his territory alone, he told me this morning that they have 4 guys that do training. That's all they do in his territory. So the qualifications for electrofusion are a little bit different than they are for butt fusion. So just because a guy's been trained on butt fusion doesn't mean he knows a lick about electrofusion. And they are indeed different. And as far as I know, and for my industry, if you're watching today, and I got this wrong, please help me correct this slide, but Integrity and George Central are doing electrofusion training, both remotely and in the field and at their facilities. Strongbridge, another member company, is starting this summer to teach at their facility in Jacksonville. And our distributors, ISCO, Consolidated, Sandale, Corin, Maine, and Secor, all have their own trainers. And if others do as well, please educate me so I can get this slide updated. But so we're getting better at providing electrofusion training in the field, whereas back in the day, it was either parking lot training or you had to go to George Fisher or down to Integrity in Atlanta to get your training. You look at that image on the right. I mean, those guys really take time to write on the coupler or the pipe of what they did and when. You betcha, absolutely. And that's something that as inspectors we look for. We look for that sort of documentation be done on the pipe, because those cool times and the fusion times can then be reviewed. If you get busy or have to take a call or you go off to work on another electrofusion, you know where you are when you come back to that one. So that's pretty fundamental. And Shannon, could you come in and tell me a little bit about the difference between a butt fusion certification and an inspector qualification? What's going on there?
So a couple different things, Pete. The one for just an operator, that's going to qualify you to operate a machine and fuse pipe on the job site. So many different classes that you can take, mostly dependent upon size for the operators. But they are generally very quick classes that are very in-depth. And once you've completed it, then you are qualified to go and fuse the pipe. On the inspector side of things, that's going to be a whole lot more in-depth. What we're looking at for the class there is minimum that you're going to spend on that is going to be about 14 hours. And this runs you through all aspects of butt fusion, saddle fusion, socket fusion.
Awesome. And I see it's $1,200 there. Shannon, do your distributors provide inspector qualification classes as well?
Most of the distributors that we have out there do offer some type of inspector's course. Okay. They may vary a little bit differently, but they all offer a inspector's course.
Got it. And some of them charge for that, I assume, and some of them may not. I don't know.
From what I understand, the large majority are going to charge, but you're not going to appreciate something unless you pay for it.
Yeah. And your class, Shannon, is that $1,200 class available online, or is that an in-person program?
So for our course, it is 100% online for the English version, and it's all self-paced. You're doing it as you have the time to do it. You can either sit down and do all 14 hours, or you can break it up into different sections.
Got it. Thank you very much. Alan, I see that our Q&A, we get a lot of questions right now. Are there any questions that you'd like to share with the group?
Well, that's part of the program here, Pete, as you're well aware. So we have a dueling program that adds any question that you may very well want to ask at any point in time. Type it into the Q&A. We've got several that have been answered by some of our folks behind the scenes. Shannon, you may want to come on and help talk about the fire that happened last week. I'm looking at 42-inch that caught fire for a project for advanced water purification in Santee. If a HDPE pipe would catch on fire, the actual ignition temperature for HDPE is well in excess of 650 degrees. Those heater plates for butt fusion machine itself is typically operated around 400 to 450. The direct question that we had was, does the data logger help prevent fires such as reported for last week? Shannon, do you want to elaborate on the data logger now? That I know you've got many slides on it later.
Sure, I can briefly touch on it. The data logger is a recording device. So it gives you the ability to record all job site information and your actual fusion information from that joint. So as far as preventable, not so much on the preventing side as in making sure that the joint has been completed properly. The only thing that you're going to do as far as temperature would be is record the temperature of the heater into the data logger information.
Yeah, well, thank you for that. And as just to reiterate what Alan said, according to ASTM F2620, which is on your screen right now, the range for temperature is 400 to 450 F. And I'm pretty sure that a heater plate does not start a fire on a polyethylene piece of pipe. In fact, I've never heard of that before. So I'd like to learn more about what that gentleman's question is. So we are asking people to use the standard, and our training is all about the standard. What standard are we training to? And in butt fusion, we use ASTM F2620. We cannot share this with you because it's trademarked. You have to purchase it. But this is available to you from ASTM. And as far as I know, everybody in the water industry trains to F2620. Moving on. So specifications. Central to success and inspection are the specifications. Anybody involved in construction knows that. Alan, could you tell us a little bit about the Alliance's specifications?
Sure, Pete. We've got lots of specifications that are available to you for what you see on the screen here for different installation type methods, and then also polyethylene pipe in general. So that's going to cover every ASTM standard, AWWA reference that goes into working with HDPE. We've got testing, both the guided side bend back test, and then also pressure testing. Those are derivative directly from ASTM standards, and then we simply provide you the language that you can include in your specification package for a bid document. We'd be more than happy to help review any specifications that you have for project specifics. You just got to share some of that project information with us. We love talking about HDPE, and we love even more talking about infrastructure projects to help you with those projects as you go through. So these are all available on the website for download, both in Word and PDF format. And go knock yourself out, everybody.
Thank you for that, Alan. All right, moving on. So pipe inspection, 3 great times to inspect pipe. 1 is when you get it, 2 is when you start fusing it, and 3 when it starts to go in the ground. So we're looking for scrapes and gouges. We're looking for the print line. So does the print line match the spec? So in this case, we've got modern polymer pipe, PE 4710, so that's the cell classification, made to standard ASTM F2619, and this is some pretty thick pipe, 4-inch DR7. So if you order DR9 or DR11 and DR7 shows up, you're getting a thicker pipe, but it also has a little tighter ID. Learn how to read the print line. So when you get it on the job site, look at that print line. And then finally, check your OD and your DR, and does it match what it's supposed to be? So it's in the spec, scrapes and gouges. Alan, what are we looking for on scrapes and gouges? I know we've got a slide a little bit later, but we touch on it here. What is acceptable?
So the pipe has a 10% gouge allowance that if we did not exceed that 10% of the wall thickness to the pipe, Pete, then that pipe can operate within its 100-year plus service life as normal. So we sometimes scrapes and gouges do happen in the field. Later on, we'll show an example of what is a bad scrape and what is example of a tolerable scrape. What I like to say, Pete, is when in doubt, cut it out. And that's just another fusion that you'll put through right there and save some time.
So while we're talking about it, Alan, certainly the trench is in your area of expertise. Why don't you handle the next couple of slides?
Oh, absolutely. So what we're looking for in that trench happens to be a solid foundation that's free of rocks or other things that would damage the pipe, the bedding that's placed underneath it, to be able to give it a cradle in order to be able to hold that pipe. Then we have embedment and backfill and compaction of those materials. That's a video on there, Pete, if you want to get that started. So what you're seeing here happens to be placement of compacted or backfill material on top of a pipe that in a different video we had showed you the cross section of the trench. That max particle size is what we're looking for 6 to 8 inch pipe. That's a 3/4 inch particle size. So what that means essentially is a 57 stone, which settles out of a 57 sleeve when they're sorting through material. And that's often used to stabilize the bottom of the excavation to be able to make it so you can dewater that with a sump pump. And then also that can come all the way up the side and compact over a 6 to 8 inch pipe. So we've got those compaction numbers for you in our specifications if you'd like to take a look at them. And what you're seeing is actually a perfectly safe method for installation with less people in the trench. That's what we really like to see. So advance to the next slide. There we go. We're showing you some processes and procedures itself. We want to make sure that the valves, hydrants, mechanical couplings have bolts that are going to be resistant of corrosion. We want to take advantage of that pipe material being corrosion free and try to make sure that the pieces and parts that we put back together to connect it to metallic parts within the system are free of that corrosion as well if we can. So we do have detectable underground wire tape. So that's either a metallic tape that you can latch onto and detect where that warning tape might be. They also do it without metal tape. Tracer wires follow the location of that pipe for us and give us a detectable asset because the high density polyethylene does not convey electrical signal through it. We have to have a mechanism to do that. And then an RFID marker ball can send that signal directly to the surface of where that pipe is buried.
So Alan, I like the images you put on this slide. On the right there, we have American AVK's Series 66 classic hydrant, but in this case we have a polyethylene stubbed end, so you can just butt fuse or electrofuse it in line to your polyethylene. In this case, looks like a 6-inch polyethylene stubbed end. And then we have that metallic clamp is George Fisher Piping Systems product, Alan, that coupler that is connecting the PVC to the polyethylene. So that functions as a transition. Pretty crazy product there.
It does, Pete. We recognize that your valves aren't going to be made of polyethylene. They don't make them that size. So we do have to have a restrained joint when we're connecting to other things. This is a good reminder time, Pete, that when we butt fuse or electrofuse, that is considered to be a fully restrained joint, which is one of the beauties of polyethylene through that process.
Yeah, and this electrofusion here, Alan, also a fully restrained joint. It is not something we have to pour concrete over. Is that correct?
That's correct.
One of the things about this image, Alan, that I love, we talk about cleanliness, yet, Alan, we're in a trench. I mean, most trenches I see aren't really clean. How do we account for that? How do we get it to the point where it's safe to do electrofusion or butt fusion?
We dewater the excavation to the best of our ability, and then make sure that when we do have access to the places to which we're doing electrofusion, that it is free and clear of dirt and debris and water as well. That's another video, Pete, if you want to click on the video, and we can kind of narrate through this as well. So once we do have access to the location as to which we are going to perform electrofusion, and of course, Rick will talk more about this a lot later. We'll come through and make sure it's completely free of dirt, debris, and we will clean that sucker, that pipe enough for us to be able to clean it with soap and water, and then dry it and put isopropyl alcohol both before and after scraping that pipe there. So, oh boy, that construction worker is pretty happy. Oh, there you go. Hey, that was a successful handoff, Pete. Go ahead and keep going. Now you take over.
Yeah, that's a handoff. Yeah, so he's got a George Fisher electrofusion processor. The guy just threw him some isopropyl wipes, which is pretty common in this industry. You know, Alan, for a long time we'd use spray bottles, but now there's a proliferation of these wipes. So those are 90% or greater isopropyl alcohol. But Alan, what's up with WD-40? Why is it you have that in here?
You put that in there, Pete, and I made sure that we tell everybody not to use it. So it's got an oil-based type product. We certainly don't want anything within the interface of the electrofusion zone or butt fusion zone itself that's a contaminant. And we certainly good practice to not clean it with WD-40, Peter.
So, Alan, before we move into PPI's guidance on this, you know, certainly adjacent utilities are important. These procedures, the inspector's got to pay attention. You know, like on this image in the middle, that's an older image, Alan, before PPI pretty much mandated you got to use peelers instead of scrapers. But I can see by looking at that, it was scraped because the scrape marks are parallel with the pipe versus at 90 degrees. Back in the day, that would have been acceptable. But today we're looking for peel marks, aren't we?
That's correct. So those are going to be perpendicular to the surface, and the tools providing that peeling to get back to virgin resin material, that's what we're trying to achieve, have developed fairly significantly. So we'll certainly talk more about it as the presentation progresses.
Thank you, Alan. So we're looking for good procedures, as we talked about in one of the first slides. Mechanical couplings. Hey, if you can't get it dry, you can't do electrofusion or butt fusion, we want you to use mechanical. And the industry provides a variety of very capable, very stout, long-term life mechanical couplings. So that's good. And according to ASTM F2164, there is no leakage allowance for a section of HDPE fused pipe. Any leakage is considered a failure, and we solve for that. And Alan, the MAB of the Plastics Pipe Institute has given us guidance for pipeline inspection. Tell us a little bit about MAB 06.
Sure. The Municipal Advisory Board is a group of municipalities within the Plastic Pipe Institute. So they work directly for the municipalities and learn a heck of a lot while installing and working with HDPE pipe. So they've given us some great detailed forms to be able to just take right out in the construction world, to be able to track this installation from incoming materials, equipment qualifications, connection inspections, pressure testing, all sorts of different things that are very helpful within this guidelines for HDPE pipeline inspection.
Well, it's incredibly thorough, Alan. And they've Camille Rubiez at PPI has also published Technical Note 60. Tell us about TN 60.
Sure, this will tell you the different methods that are available to do non-destructive testing for your high-density polyethylene pipe. So there's a lot of visual inspection that can happen for us to look both at the bead, see if it's done correctly, and then also the processes to which we're fusing. Talk a little bit about the data logger, which Shannon will elaborate on fairly significantly, and then even in moving into some non-destructive testing evaluation in materials in their infancy. So lots of good information there for you. And again, PPI and the MAB have those for free on their website.
You know, Alan, I'm a big fan of the data logger. And if Shannon, you could come on now. And the reason, as I said earlier, Alan, is it provides on the butt fusion side anyway, basically universal coverage of what's going on in the job site, even though you're not there. Shannon, the data logger is something that McElroy developed many years ago, but it wasn't until probably the last 5-8 years that it's really come into its own, where it's a staple on most polyethylene job sites.
That's correct, Peter. You know, some of it has to do with standards, some of it has to do with popularity, and some of it really has to do with changing from the smaller data logger 5 into the tablet version that we started with the 6.
Sure. So the guts, Shannon, of the data logger, all are about making a qualified fusion joint. Tell us about the structure behind the design of it before we start talking about the hardware.
Well, most importantly, Peter, you know, over the years, since everybody's started fusing butt fusing, the one thing everybody wants to do is actually make those joints correctly. We can get a lot of information from looking at the bead. We can get a lot of information of seeing how the pipes are aligned. But a lot goes into making sure that we have a proper fusion joint. As you look at what we call the fusion matrix here, all these things have to come together in order to make sure that when we put in a pipeline, everything's going to be done successfully. The qualified procedure, you know, we've got qualified procedures from ASTM and PPI. We've got qualified operators through different training programs that we offer, electrofusion companies offer, all of our distributors offer. There's a qualified material, making sure that we're using products that are well-known products that are extruded to a standard or molded to a standard. And then there's qualified equipment. Of course, I'll say that, you know, all the folks that are members of the P Alliance are all qualified, but the biggest thing that makes them qualified is that they are in use every day and they are built to different standards. Just like the ASTM F3124. So this is a procedure or standard that was put out by ASTM that actually tells you exactly what's required in a data recording device on the job site. And of course, the data logger adheres to all those different procedures and standards for ASTM. And of course, the data logger itself. The data logger can be hooked up and record joint information for any machine that McElroy manufactures that has a hydraulic port that allows us to connect a pressure sending unit to that. And then we can record all of that information. And this is our latest data logger, the data logger 7. It gives you the ability to not just use the touch portion on the screen, but it also has hard keys on the right so that you can utilize those if you would prefer to use the hard keys. With this image here, if you can go back one, just Pete. This is one of our newer machines that's out. This is the I-Series machine. And so we've gotten so used to using a data logger in our everyday use on a job site that the new data logger 7 is actually incorporated into our TrackStar I-Series line of machines. And it actually runs the machine through the data logger. So as we go to start inputting information into a data logger, pretty simple. Once we turn the application on, it gives us the ability to add process type, joint, job, operator, and machine. And it's real simple. You click on a button like select an operator. If an operator is not already in the system, you'll click the plus sign and add that person's information. Picture what their name is and who issued their certifications. And then it's the same thing. We would go back. We can do the same thing with machines. If we click on machine, it gives us the ability to go in and add all the different machines that data logger is going to be connected to. Then back at our home screen, we go in and we go to our process. Many different types of fusion processes that you can do. For this one, we selected butt fusion. And for specification, we're using an ASTM F2620. And again, back to the type of fusion. Most of the time we're using it for butt fusion, but you can see there's many other options available. Before we go any further with the data logger, as you're going through that setup process, really where we're going to start beginning with this is after we've faced off the pipe. So we can take photos to show that we have proper alignment and a good face-off.
Shannon,
Yes.
I can jump in. That photo requirement would be a great thing to add into your specifications for the job. If it's not required, some operators tend not to take them, but we get a lot of information as inspectors by seeing the different stages, whether it's face off, the final bead. It can save us a lot of time and really give us a ton of information.
And the
Dave,
data loggers can be,
Sorry, Dave, I totally agree, but I've had some guys complain to me when I say that it takes up too much space in the data logger. So Shannon, what kind of what kind of memory does a data logger have?
It has a very large amount of data space, Peter. We have data loggers that we have thousands of joints on, and everyone has pictures. We've not run across the issue where we've had the data logger actually absorb all that space. In addition to that, at the end of this presentation, we'll talk a little bit about the vault. So that's the secure cloud-based server where all these joint reports should live at the end of every day's Fusion. So weather conditions, we want to make sure we input all the weather conditions so that we can record any changes or anything that might be a little bit out of the normal Fusion process, whether it's way too hot, way too cold, or we know we're getting some type of moisture during that Fusion process. We have to make sure that we enter into the pipe information because that's going to play into the actual calculation for our Fusion procedure. We can change the OD of the pipe, the wall thickness, the pipe material, and then we can also change whether it's identical pipe or we're going to a different DR or wall thickness. And then we also have a traceability button, which is going to allow us to dive in just a little bit deeper. And with that traceability, we can actually trace those parts, whether it's pipe or fittings, by manufacturer, lot number, and production date. If you did have a barcode, that would give you the ability at that time to scan that barcode. So it would automatically capture that information. And then once our pipe information is entered, this is the point where we're going to enter in our drag pressure. Drag pressure, to explain it real simply, is just the amount of force that's going in the opposite direction away from the Fusion area. And that's, of course, would be a part of any Fusion class that you would be in. But it's big thing to remember here is that it's part of the Fusion calculation.
As an inspector, drag pressure is an important thing to monitor as well. If I look at a series of reports and they all have the identical drag pressure, then I've got a clue that maybe our operator was not checking drag pressure on every fuse. And one of the beauty of the data logger is it does provide you this guided workflow for the operator to follow all the way through each one. So we make sure that we're getting consistent processes all the way through. So we're always looking for a little variation in that drag pressure. We'll see some if there's an in-ditch fuse or a tie-in as well. We'll see variations.
Yeah, thank
That's
you, Dave,
correct.
for that color. Alan, go ahead. You have a question.
Sure. We just got a question about whether or not the data logger can indicate where stationing was. So that's often used to identify length along a project profile and then reach identification. So take it away, Shannon.
All right.
Questions.
So lots of questions, and we'll definitely talk about the location at the end of this. The other thing that I'll add in before we change slides is any of the folks that are out there have dealt with any type of HDPE realize that HDPE stick pipe isn't exactly straight all the time. Sometimes it have curves and bends in it, which you will notice during the drag process.
I'd like to add my version of what drag is, Shannon. You
Sure.
call it pressure away from the fusion zone. I like to say it's what's pulling on the pipe during fusion that you need to account for, because fusion is a mathematical equation that says how much force we need to connect fuse side A to side B. And if I have a 500-foot string of polyethylene pipes, 10 sticks sticking out there, it's going to be pulling on that fusion zone. So you've got to tell the machine, hey, account for that so that your fusion pressure is correct. Did I explain that well?
You did. And a lot of times when we're dealing with long runs of pipe, it's not so much that we're trying to drag that pipe on the ground or drag it in rollers. It's actually pipe stretch that we're trying to overcome.
Ah, okay. That's excellent. Thank you.
And then as we prep that machine, once that calculation has all been put together based on pipe and procedure, interfacial pressure and drag, at that point, it's going to tell us that we need to set our pressure to 308 PSI or whatever that magic number is once we do that calculation. So this is where we'd actually increase our pressure on the machine to 308 PSI to reach that fusion pressure. And then we would take our temperatures of our butt plates on each side. The machine has the ability to let you do up from 1 to 4 different temperatures on each side. You would just hit that flip heater plate button, and then you can measure the temperature on each side. And within that circle on the left there that says side A, you can see it's got a darker gray area. That gives you an idea of where you actually need to take the temperature based on pipe size, because we want to make sure that we're taking the temperature of the butt plate in the area where the pipe's going to come in contact with it. And that's on both sides. And it tells you your range right above that. So at this point, we've entered in all of our information that we needed to. And so we would put our heater into our carriage with no pressure on the system. We would click Start Fusion. And then from that point, the machine is going to record any hydraulic changes during that process. And then once the fusion itself is complete, at that time, we're going to click Done. And when we click Done, it's going to say, are you sure you're done? And then, of course, we would be sure. And we would click that Done button. But this gives us real-time information of what's happening during that process. So this is that first QC that we have during the fusion process. And this is on the operator. This gives them the ability to locate or notice anything that's going outside the normal process so that he could abort and fix it immediately, or he can go through and know that he's gone through the fusion process correctly.
So Shannon, how long does it take to teach an inspector that's never seen this report before how to read this graph of what happened in the hydraulics of that fusion machine?
It's pretty simple, Peter, because once the fusion's completed, it actually has a color-coded overlay that's going to guide the inspectors on knowing whether or not that yellow line, which is pressure, has been done correctly. And so this is the information that Pete just skipped through was just, it was the who, the what, the when, and the where. So all the pertinent.
Yeah, we'll go back to it. I just want you to speak
Okay.
to this graphic.
So this is the completed joint itself. So this is the first person that's going to see this is the operator. As soon as he clicks Done, this is what's going to pop up. And so right now we're looking at the front end. So if you look at the very far left-hand side of this joint report, where the yellow just starts coming in, we see that it ramps up to where the cursor is right now. And then we can see that real quick drop in pressure. So that pressure that was maintained at the very top there, that's just maintaining contact or initial melt, depending on pipe size. And then we're dropping down to drag or below. That green shaded area represents drag. That's that pressure we have to be at to find that zero during the fusion process. And then we move into our open close time in the red shaded area. So this red shaded area, if you'll click the next slide, this represents the maximum amount of time you have to remove the heater and bring your two jaws back together under pressure. And so you can see that all those changes in pressure, which is indicated by the yellow solid line there, happen within that shaded red area. So you know that you met that maximum amount of time allowed. And then we go into the summary, which shows our complete joint data information. What we're really looking at on this process is we're looking at that shaded blue area that represents the cooling time that's required to meet the procedure requirements. And of course, you can see on this that yellow line dropped off about 60% of the way through the cooling period. So instantly, an inspector that's looking at this can know really quick, okay, you didn't meet your cool time. You either lost power, you lost fuel, or you just shut the data logger off. And so we've got that pressure drop indicating that you did not meet the full cool time of that joint. So then at that time,
I'm sorry, this would be a good time to talk about the concept of interfacial pressure, which is the theoretical amount of pressure it takes to diffuse 1 square inch of pipe, and how for any given DR and size, there's going to be a range of pressures that are acceptable. And that's why we see that band at the bottom of the range representing a 60 PSI interfacial pressure and the top representing
Correct.
a 90 PSI. Earlier on your screen, you had shown that we had set this at 75, which is why it shows up there right in the middle.
that's
Yeah,
correct.
good point.
Dave.
Yeah,
That's
thanks for
correct.
doing that, Dave. So anyway, Shannon, with this graphic representation of a fusion, inspectors can look at this report from the comfort of their office the next day, the next week, or the next hour after the fusion, and say, hey, I want to put that pipe string in the ground. And the inspector says, wait, I haven't looked at the data logger reports. Give me 10 minutes to look at these reports. Is that right, Shannon?
That is correct, Peter. And one of the things that I've run across in teaching the many folks that I have for operations and for inspectors, they find it not nearly as intimidating as they would think. A lot of folks may find technology a little bit intimidating, or they just moving into new products can be intimidating.
Right.
But having the guided workflow and then having that color-coded graph overlay has really eased the pain of change.
Yeah, for sure. Hey, Shannon, we had somebody just ask us, hey, should I use this even on an easy 4-inch? Should I use a data logger?
That's kind of like asking, are you sure you want to do it right?
I
Is
totally
the easiest
agree.
way for me to answer this.
Yeah.
So I would go as far as to say I would use this for pretty much all types of fusion and pretty much all sizes. So if you don't have a hydraulic port, that's okay. You can still enter in all the information, the who, the what, the when, and the where. You can still take pictures. You can still add notes. And then you can also get the GPS data. So the second that that joint is completed, you're going to get a GPS coordinate of where that fusion was located. One of the things people always ask me is, well, we're going to pull that thing, that pipeline down 3 miles, and that's okay too. Mark your joint, take a measurement, and then go take your data logger to where the joint now lives and create a new GPS coordinate.
And it all exists in the cloud and it's accessible well after the fact. Is that correct?
That is correct. What we recommend is that on a daily basis or live, if you've got a hotspot, which most folks do with their phone, you're going to connect your data logger to that hotspot and allow it to upload to a secure cloud server called the Vault. This Vault is secure to you. Only people that are authorized to view it may view it based upon username and passwords, but you can still share those joints with anybody that has a Vault account. So a lot of times people that are new to the industry are going to share it with their distributor or even the guy who trained them and go, hey, can you just take a look at this? And at that point, somebody may say, hey, McElroy, can you take a look at this and just let us know, does this look okay?
All right, we need to get through butt fusion here. We're running a little late, Shannon, but tell us a little bit about your training from your perspective.
So butt fusion training is where the heart of it all kind of lives. It's fairly simple. It just takes a little bit of training to make sure people are set up for success. The way our training is put together, we've been doing it since 1981 in more of a formal setting. We can do training here in Tulsa on our different campuses, or we bring people to different job sites. We send people out to do not just operator training or inspector training, but we do maintenance and repair training. And then there's always continuing education as well. We have that continuing education in there because there's lots of different training opportunities that are available that you may just need to go through and do a refresher. And that training is usually done in a combination of ways. All of our butt fusion training, all of our saddle socket, all that fusion training is done on the front end with web-based training so that you can go through and do a self-guided training. And it's not just videos. You're not hopping on watching videos. This training that you're going to do through our learning management system is actually interactive training that's done on the web. Once that's completed, then you would do your hands-on training. And again, at your location, one of our distributors are in Tulsa. For the inspectors training, all of our English speaking classes are 100% online, and it's 14 hours. This is just a real quick snapshot of the agenda, and it's not the full agenda, but there's a ton of different information that's going to be covered in that class, starting with your introduction and then running through the different fusion types. And then we get more into the testing of tools, materials, and accessories that go into that to include the pressure testing. One of the things that will be covered in that class is the guided side bend back test. So a lot of people that have been in the industry, one of the first things you'll learn about is a bend back test. It's where you're cutting out a strap of pipe and you're bending that back to try and see if there's going to be a break in the joint itself. With using the guided side bend test, it allows you to actually put a mandrel directly on that joint and apply pressure at the joint. So we know exactly where we're going to apply that pressure. It's not going to go left or right of the joint, but directly on that joint itself. Prepping material to get it to that point, you're going to cut out a strap, you would turn it on its side, and then you will plane it down to 1/4 inch, and then stick it in the guided side bend tester and apply pressure until you reach 90 degrees on that.
Yeah, that's a fantastic machine. Dave Mosier, do you sell those or rent them, or do they
Yeah,
have
we
to
rent.
come from McElroy?
No, we actually rent those. We send out a kit that includes the planer so that you can make your sample. It does take a little while to do that, to make that sample. So we typically see this used at the beginning of a job, whenever we deploy a new piece of equipment to an existing project, or whenever we change operators on a job. We won't do it every day, but when we have one of those three circumstances come up, then we will do a guided side bend test.
Well, Shannon Land, thank you very much for your thorough review of butt fusion inspection as well as the data logger. Rick Ponder, why don't you come on and tell us a little bit about electrofusion training, and then we'll talk about electrofusion inspection.
All right. Okay, well, electrofusion manufacturers, typically, we all require that anybody who's going to be installing an electrofusion fitting, that they be trained and qualified an authorized manufacturer trainer. PPI with the Municipal Advisory Board also requires that installers be trained and that they by an authorized trainer themselves. That usually requires 4 different things. That the person doing the installing needs to be able to attend personally some sort of classroom instruction. They need to be able to successfully complete all of the required certification tests which go along with the classroom. They need to be able to prepare and complete a joint assembly, and it needs to be witnessed by that authorized instructor. And then those test assemblies that they put together have to be able to pass an ASTM destructive testing requirement, which is a crush test. We have different levels of electrofusion training. The first one would be the level 1 training program, which is what we consider that small diameter. That would be 12-inch and below. And this is typically designed for the new, less experienced, or even just people who have been doing it for a while, and they're not going to be doing anything larger than 12-inch. The level 1 program typically focuses on the what, the why, and the how of electrofusion. So we want people to have a good, solid understanding of the basics moving forward. We also have a large diameter, which would be 14-inch and larger. This is one of those to where it's not for the newbie who's in the field, or the very unexperienced. They really need to have a better grasp, because there's a lot of subtle nuances because of the differences in the pipe size and weight. And when we do that, we require that they at least have a level 1 certificate held by some other manufacturer or ourselves before going on, or that they would have a level 2 and they're being recertified. And when they do it, we would like them to have some level of experience before doing such. Okay, when we go in on the fitting, when you're going through the training, we want to look at the proper cleaning, the clamping, aligning, the facing, and the peeling on this. Now, it looks like we're doing on the butt fusion right now. I guess we're on the electrofusion right here. We want to, electrofusion is one of those things to where it's kind of an invisible process, unlike the butt fusion, to where we can actually see what's going on, and we can have any control over the temperatures and times and pressures which are being applied to the actual fusion face. They're built into the actual design of the fitting itself. So we actually focus on the actual procedure itself. What else do we have there?
I think we've got one more slide here on the bead inspection process, Rick, which you're absolutely correct. It's much more butt fusion. Before we move right into the material that you've got for electrofusion inspection as well. So this is just simple bead inspection for what would be appropriate to be able to look through, and our ASTM guidance and PPI guidance as well shows us what we're trying to look for. So if you advance to the next slide, we'll get to the electrofusion inspection. Rick, I believe this is where yours really gets started for us here, and that will do it for you.
Yeah, like I was saying earlier, electrofusion is different than butt fusion in that we use engineered fittings to achieve the same thing that you're using with a butt fusion machine. Like I said, typically you're dealing with temperatures, times, and pressures. And the difference with the electrofusion is in how do we apply those temperatures, those times, and those pressures. Those are built into the design and the design of the fitting and the use of the fitting fusion times itself in order to generate a melt pool. One of the key elements in electrofusion is proper preparation, because the whole thing about the electrofusion is you've got to get down to virgin resin. We're actually fusing on the outside surface of the pipe instead of butt fusing the face to face of it. So we want to make sure that everything is clean, it's properly prepped, there's no contamination away, so that we can get a proper melt pool and mixing of the material. Typically on the electrofusion issues that we have found over the many years doing this stuff, historically and statistically, they've fallen into just a handful of categories. I've seen it to where it's primarily improper electrofusion fitting storage. You can't store these things outside of their bag because you have a fusion wire, which is basically embedded into the fitting, and you don't want contaminants getting to that. So storage outside is not good. There are power supply related issues. Are you using the right size? Is it well maintained? Then you have processor related issues. Are you getting enough power from the power supply to the processor? Is the processor putting enough power out to the fitting? And then we have improper procedure and assembly related issues. And that's what we all cover in our training programs. What we require are properly trained fusion techs, because we're using engineered fittings with a qualified procedure. This right here is showing the different thing where the fittings are stored outside, and you can see right here where the fittings themselves, where the molded fittings these fittings have the wires embedded into it. Next.
So
slide.
what's the issue with storing them outside? I mean, to a contractor, I mean, that's like heresy. I mean, everything that they use, Rick, is outside getting ready to be used on the day they need it.
Well, it's, storing it in a shipping container or under a covered area is one thing, but if you have it out on a pallet in an open field when it's been raining for a week and a half, you're going to have a lot of mud, and those, the cardboard boxes and the bags can only protect the fittings so much. We want to try to keep the contaminant, any potential contaminant, from getting inside that packaging and getting inside those fusion wires. Because once you get mud and contaminants inside those fittings, you can wipe down the surface, but you may not be able to get all the contaminants that may go down into those embedded wires.
All right. So you're an inspector and you see a contractor bringing his warm 70-degree couplers from his office to a job site, and it's 18 or 20 degrees outside. What's your advice to that inspector?
Well, okay, now that's a little bit different situation than stored and outside for a long period of time. If it's coming from a warm environment to a cold environment like that, the fitting hasn't acclimated to the outside temperature. So, you're going to have a little bit of expansion and contraction that you're going to have to deal with depending upon which way the temperature's going. So you want to be able to bring that fitting and at least leave it outside long enough to where it can acclimate to the temperature that's on site, so that it will expand or contract, to the same dimensional properties as the pipe itself.
Good, thank you.
Okay, we're looking at pipe problems versus fusion tech problems. Okay, we have two different areas right here. We have, ultimately the buck stops with the one who's putting the fitting in the ground. There are some issues that are pipe related that the installer is responsible for being aware of and basically addressing them, and that may be like out of size pipe, particularly undersized pipe. It's not something that happens a lot, but it has happened. So he's responsible for checking to make sure that the pipe is within spec. There are flat spots on the surface of a pipe sometimes. If it's in the fusion, particularly in the fusion area, those need to be addressed. Excessive scrapes and gouges, he needs to be aware to see if they exceed the minimum 10% of the minimum pipe wall thickness. Toe in is something everybody's going to deal with. If it's excessive, he's going to have to effectively deal with that and cut it back. Now, there are other issues that the installer is responsible for that he is completely responsible for. And these have to do with procedural and preparation type of things. Has the pipe end been cut properly? Plus or minus, no more than plus or minus from a 90 degrees. Has he marked the stab depth? Has it been short stabbed, over stabbed? Has it been misaligned? Is it in a straight, stress-free, non-binding situation, or is it in a binding situation to where you're going to create excessive gaps? On large diameter, is he using rerounding clamps to make sure that the pipe is effectively filled, where you don't have an excessive gap inside the coupler on one side or the other? Did he scrape it correctly? Did he use correct scraping or peeling tools is what we're supposed to be saying, peeling tools? Is the area free of water? Is it dry? Is there any water trickling through it? He's got to be able to address those things, because all of these, take any one of these things together, can have an impact on the electrofusion joint.
So you're making it sound like it's a little fragile, Rick. What has your experience been with experienced contractors and their love of electrofusion?
Fragile is not really the word. It's a very robust fusion procedure, but it does require that the installer be trained and qualified, and he needs to follow proper procedures. I mean, electrofusion fittings are not magic fittings, and electrofusion processors are not magic boxes that you just push a button and go. There are certain things that you need to do, just like you would have to do with butt fusion. You would want to make sure that with the machine, it's level, that you're facing it properly, that you have the correct interfacial pressure. We do too. We require those same things. It's just that the fitting itself is actually doing all of that stuff that would be more, I'm going to use the word operator dependent on butt fusion, because you have more control over it, where the electrofusion fitting is more designed to take that stuff, to deal with that itself by the design. So you need to follow the procedures.
Fascinating. In fact, Europe uses more electrofusion than they do butt fusion. And they're more well-developed in their use of polyethylene in the municipal water and wastewater markets. So that tells you something right there, Rick, that they have a lot of confidence in electrofusion and electrofusion procedures. So Shannon and Dave, if you guys could come on, I have a question for you, Rick. When I talk about electrofusion saddles, Rick, and I see people in the field, they tell me that sometimes the saddles pop off. That's the most common complaint I get about electrofusion. Why would that happen?
Well, I'll jump in. It's gonna happen because they haven't properly prepared the pipe. And in the 10 years, 11 years that I've been doing this, we've made such advancements, not only in the training such as Rick provides, but also in the quality of our tooling. We're able to remove a consistent diameter from the pipe to get down virgin material. We have rerounding clamps that are getting our pipe back in perfect roundness before we do the electrofusion, that we are not seeing those anymore. We see some pop off in the past, and we could see that they were roughly scraped, maybe even using some sort of abrasive tool, or they badly gouged or something like that. So our apprehension on using this has gone down tremendously. I've recently put 10 people through Rick's class, and it's first class training.
Yeah. Well, thank you for answering that, Dave.
One of the things that I would like to add to that, if possible, is that there are different electrofusion manufacturers who provide fittings like that. Each of those will use clamping devices for those fittings. So it's important, whoever's fitting that you're using, that you are using either the supplied restraint device or the one that's recommended by that manufacturer. Because if you don't, you could end up getting yourself in a bind where you're not creating enough pressure on that fitting to get the fusion that you want.
All right, Dave Mosier, tell me about what you see on the screen here. Which one's good and which one's maybe not?
Well, I'm not happy about either of those. And as Alan said earlier, when in doubt, cut it out. The only bad fusion joint is one that goes in the ground that shouldn't go in. So in both of these cases, I would take a quick look. The one on the left may just be superficial. I would typically scrape that down with a scraper so I can see exactly how much is taken out of the pipe and how much is just plastic that's been pushed to a higher spot. The one on the right, though, that definitely would be a red flag for me.
Yeah, so actually we do sell micrometers where you can measure the depth of the gouge. So as Alan said earlier, we're allowed up to a 10% scraper gouge. That would be of wall thickness. So thank you for that. Our next one is one of my favorites. This would only show up, guys, if we were doing a hydrostatic pressure test on a super hot day. Is that right, Shannon?
That's something you're not going to see very often, Peter. This is a massive amount of pressure, and usually the only time you're going to see something like this is in the actual pipe facility where they're testing that material and putting under massive amounts of pressure.
Yeah, thank you. How about this one, Shannon?
It looks like they had that thing on there for about 6 times the amount of time required to heat that pipe.
But why would we get a wavy bead?
There's many different things that can do it. When I see it, generally a lot of times when I see it, it's a maximum amount of heat has been put on that, and it could be caused from overpressuring as well, putting too much fusion pressure on the joint.
Or banging it when you're pulling it out. You're in the after the heat soak maybe, and you're inside the 30-minute rough handle time, maybe.
That could possibly happen if you're trying to move that way too soon. I mean, realistically, you would have to bring your 2 molten pipe ends together and then remove the jaws within seconds and try and slide that piece out, which unfortunately has probably happened. But that would definitely disrupt that molten pipe bead.
So as an inspector, Shannon, what should he or she look for as it relates to that 30-minute rough handle time? How are they supposed to keep track of that?
The easiest way is just be able to use the data logger. I mean, realistically, that's an answer for a lot of the questions that I get is use the data logger. A lot of companies that are out there do keep a paper sheet of what's going on for that joint information. They will record when the joint started, and then they will record when that joint stopped. So at a bare minimum, you got to capture the pertinent information. Who did it on what machine, what size pipe, what procedure, when the fusion started, when it ended.
Thank you, Shannon. All right, Rick, tell me what's going on here.
Well, there could be several things right here. You say out of spec pipe or the DR not matching the fitting. This is not a DR not matching the fitting type of issue. This would either be an out of spec pipe, or it would be one that's in a binding situation to where you would allow the escape of interfacial pressure in one part of the fitting. So that would be what we would be looking at in that.
So I would look at that and say you had a gap. Am I wrong, or is it just another way to look at it?
No, that's a gap. And when you have a pipe that's under spec, that means that you have a electrofusion fittings are manufactured to very tight ID tolerances. And if the pipe is not within the OD tolerance, then you will have an excessive gap, which may exceed the ability of that fitting to fill the gap and do the fusion.
Oh, I see.
But
All
as
right.
Rick said, is if that's under tension, if it's not in there completely straight and being held with zero tension, as the pipe melts or the melt occurs, it can actually force it to displace the material, push it up from the bottom out through the top. So that's why we use clamps and make sure that we're not doing electrofusion under tension.
Right.
Got it.
Straight, stress-free, non-binding.
All right, Rick, you get one more.
Okay, well, you can see on this right here, on the one on the left, you see a little white mark right there. So that means that they at least marked a stab depth on that fitting. So that's telling you that that little white mark is up to the end of right next to the coupler. The pipe end is going to be exactly in the center of the fitting. Okay, so because we have that much room right there, what ends up happening is that we have a misstab situation in that. So we're going to lose our interfacial pressure.
And what's the image on the right show us?
The image on the right is a miscut pipe. All of the standards basically say that you want as straightest to 90-degree cut as possible. No more than plus or minus 3 degrees deviation in it. And this obviously exceeds it.
Got it. Well done, fellas. Now I'd like to bring Dave Mosier back and Alan Ambler to talk through some of the issues we see with pressure testing and how do we go about doing a proper pressure test.
So as you see, ASTM 2164 does address the pressure testing procedure. It is similar, but not identical to the pressure testing that you'd be doing on a PVC or ductile iron, in that you do want to bring the pipe up to a specified pressure and hold it there for an amount of time. But as Alan can tell us, polyethylene pipe reacts to 2 things: changes in temperature and changes in pressure.
Absolutely, Dave. So there's an important distinction here, and part of that happens to be the DR rating, or the design pressure of the pipe itself versus the design pressure of the system that we are installing the pipe into. So if we do a test pressure to 1.5 times the design pressure of the system, the operating pressure, we want to make sure that we don't blow the weakest part of that component as well. And so that's an important part of it. A good distinction would be DR11 is often used for potable water systems at 200 psi, but yet most water systems operate from 55 to 70 psi. So that operating pressure is very different. What happens with the pipe? The material, since it's viscoelastic, has to go somewhere, and it expands diametrically that way when it's pressurized from internal pressure. It's called Poisson's effect. And then we'll also see temperature effects as well. So if we start to increase the temperature of that pipe, let's say it's above ground out in the surface, and we're starting to pour all that sun on it, that expands in a certain direction. While we have a stable pipe, so we'll charge it beforehand and then reduce it 10 psi to continue to watch the pressure. We should have filled all of that expanded cavity from Poisson's effect or temperature effects as well, and we wouldn't see any amended water through that process. So keep going there. Dave, you're going to close this out.
Yeah, so a couple of best practices. We do recommend doing pressure testing early in the morning as opposed to mid-afternoon. Obviously, our temperature can get to extremes in the middle of the day. So we're going to want to do that earlier. We want to make sure that we're mitigating any any air that's in the system. And again, this is a leak test using hydrostatic pressure, not necessarily a pressure test. That's done at the plant when the pipe's manufactured. So we're going to eliminate eliminate the air. You can probably go to the next one there, and you can see we've got the pipe is a little higher on the far end where we're releasing the air out of the system. And you can compress air. You can't compress water. You can put water under pressure. So we want to make sure that all the air is out of the system as well. We're going to get the fuse pipe, a hydrostatic pump. That'll give us a very precise amount of pressure being placed to it. Of course, you need a source of water. We like to use the data logger. We can actually hook that pressure port up to the testing fittings, and we can record this on the data logger. And what you're going to see is you're going to have to add makeup water as the pipe responds to the pressure and the temperature. So we'll have up to 4 hours of adding water. We'll see a drop off slightly. We'll add more makeup water. It'll drop off slightly. But we're making sure that we're getting all that air out of there. And once we get to a stable pressure, then we can reduce it by 10 psi and hold it at our test pressure. Okay. And again, 1.5 times the system operating pressure. So if you've got a 90 psi system, let's test it at 135 to 150. We don't need to make sure that it can go to 620 psi. They do that at the plant. We also mentioned already, don't test at a pressure higher than anything else, any other component in the system. A couple of illustrations here. This is just a test one we built for down in at McElroy in Tulsa to do some videos. You can see here that the data logger can be used, and it has a pressure testing function.
Yeah, Dave, I love the fact that you can use the data logger for this too. So you can house all of the data for a project on the data logger. So pressure testing, butt fusion, you can even use it for electrofusion if you choose to. But a lot of those electrofusion processors, Dave, they also have, it's not called a data logger, but you are able to download the data from an electrofusion.
Yeah, and one of the beauties of the McElroy data logger is that it has connectability, so we can connect it to a hotspot. We can complete this pressure test in the field, get that information to the engineer instantaneously, and then proceed with our installation of the pipe. So you can see it's very time effective way to do your testing and deliver your reporting.
Thanks for putting that together for us, Dave. Nice job.
Thanks.
Alan,
For
you're up.
clarification, yeah, just the data logger as of now does not record amended water or water as it goes through a meter to be able to get into the pipe or the pipe string that you're going to do, but it does handily and quickly record that pressure. So I've talked to McElroy folks, and I'm sure that's in the development works. As most things that they've got, they definitely do design these parts and pieces just so fantastically. So thank you guys very much.
Hey, thank you everybody for witnessing this first presentation of our inspection webinar. Any tips or comments, please send them to us so we can make it better next year when we do it. So Rick Ponder, great job today on electrofusion, Shannon Land on butt fusion, and Dave Mosier on all things inspection related. I so appreciate the effort you put together today. And Alan Ambler, thank you for putting this deck together.